Well, hello team networking and welcome to a new video. In this video, we are going to talk about subnetting. I'm going to just give you a very short introduction about what is subnetting. The idea here is that when you have one IP address for the network, and then if you take that IP address and you decided to use all the IP addresses available for that giving network IP address, let's say you will have 1,000 or 2,000, 5,000 different hosts in that network. Having that number, that much of hosts within one single network will simply create what we call a broadcast domain problem, which simply means a lot of those machines are simply going to be producing a lot of broadcast messages. There will be thousands of them. Hosts in that network are going to be busy processing those host broadcast messages. And also, the bandwidth of the network is going to be consumed by those broadcast messages. So the idea here is that when you have a network IP address, you can take that network IP address and break it down into sub-networks. And that's where the word subnetting is coming from. It's breaking one IP address into multiple subnet IP addresses. So that's, again, the main purpose. Now, we said we have basically three scenarios that we're going to be covering. The first scenario is when you are giving the IP address and you're asked to break down this IP address into a number of networks. In this case, we have 5. Case number 2, when you are asked to break down this IP address network into subnets without telling you how many networks, but it's going to tell you how many hosts each network should have. And then finally, we have the third case where we have multiple networks and each network simply will have multiple different numbers of hosts. So for example, we need to subnet this original IP address into 3 networks, and the first network will contain 60 devices, the other one will be 5, and the third one will be 2. Now, the problem with the first 2 cases is that you may end up having, again, a group of networks, and each one of those networks will contain the exact same number of hosts. And we said in the class that sometimes some networks may only contain or requires 2 usable IP addresses, and you assigned an IP address for a network that can contain 30 or 50 or whatever the number is. So you simply, with the case 1 and case 2, you may end up losing a lot of IP addresses. You're reserving them, but you cannot use them, and that's not a good practice. So this is, again, a very short introduction about what is subnetting. I might actually create a new video later on to talk about subnetting in general without going through the math of subnetting. But this video is all about the math that we have to understand when we do subnetting. So I'm going to go case by case and try to explain the concept. So here, let's talk about case number 1. And in case number 1, what do we have? We have an IP address, and this IP address is 192.168.100, and the prefix is 25. Now, the fact that we have a prefix of 25, that simply is telling me that the subnet mask is 255.255.255.128. That's a subnet mask. Now, how do I know that? Because this is 25. These are 8 bits. These are 8 bits, 8 ones, and these are 8 ones. You count them all together, you got 24. So it simply means this part is a single 1 bit followed by 7 zeros. So that's the first fact that I extracted from knowing that this here, 25, is prefix, so this is the subnet mask. Now, because I know that this is my subnet mask, I can come here and put my IP address, which is 192.168, and then 100, and then 0. Now, the line that's going to separate the network portion from the host portion is going to be within this area here that I highlighted. And also, because those are 255, 255, 255, I know that this part here will not get affected by anything. So no change is going to be applied to this portion here. I'm only going to be playing in this area. So what do we do in a case like that? We have to come here and put them in a form of binary. So zeros are simply 8 zeros. And 128 is simply 1 followed by 7 zeros. And now I can tell that my line that separates the network portion from the host portion is this one here. So this is the network portion, and this is the host portion. Now, he want me to create 5 networks. And because he want me to create 5 networks, I have to ask myself, how many bits do I have to borrow from the host portion from left to right so I can get 5 networks? And we said the equation that we're going to use is 2 to the number of those bits that I'm going to be borrowing should be greater or equal to 5, which is again the number of networks. So if I borrow 1, I am simply going to get 2 to the power of 1 is 1, so 2, sorry, that's not enough. And if I borrow 2, that will make it 2 to the power of 2 is 4, and that's not enough. So I can borrow 3, and 2 to the power of 3 is simply 8, and 8 is greater than 5. So I know for sure that I have to borrow 3 bits. Now that I know that I'm going to be borrowing 3 bits, let me clean up the space. I have 3 bits that I can borrow. So because I'm borrowing 3 bits, that simply means the subnet mask, those area here are still going to be converted to 1s, because again, they're going to be part of the network portion. And the line here basically separates the network portion from the host portion. So I know that my prefix now, in this case, is not going to be 25, it's going to be simply 28, because in addition to the 25, I'm borrowing 3. So that will tell me that the new prefix is going to be 28. Now, because I have 3 bits, I can simply get 8 different networks. I only need 5, so I have to list all possibilities for those 3 bits, all the different possible combinations that I can have. So we said the idea here, since I know I will have 8 networks, I'll go 0, 1, 0, 1, 0, 1, 0, 1. Then I go 0, 0, 1, 1, 0, 0, 1, 1. Then I got 0, 0, 0, 0, and then 1, 1, 1, 1. Now, as I said, because I know that I only need 5 networks, so those are going to be my 5 networks. What I need to do after that is simply keeping everything as it is. All I need to do in a case like this is, let's just put here the 1 and 1 and 1. I need to take each one of those lines here, the 5 one that I am highlighting here, and replace it with those 0, 0, 0s, and convert whatever the results back to decimal so I can show you the 5 networks. So the first network is simply going to be 192, 168, 100. Remember here we said nothing's going to be applied here. No change is going to be applied here. Only change is going to be applied here. So the first one I'm going to be using is simply 0, 0, 0. So I'll get 0 here with a prefix of 28. The second one is simply going to be 192, 168, 100. Now we take this one and you put it here. So I'm going to get 1 at this point, and that will make it, there's 1, this is 2, this is 4, this is 8, this is 16. So I'll have 16 and the prefix of 28. And if I go to the third network, I replace this one with the third network here, which is 0, 1, 0. So let's go ahead and fix that. And this one also. So we'll have 1, 0, and that will make it 32. So 192, 168, 100, 32, and 28. And then finally, I'm still not done. This time, I'm going to use the fourth one, and the fourth one is simply going to be 0, 1, 1, which is, here it is. So that will make it 192, 168, 100, and it's not 64, no. It's simply 32 plus 16, so that's 48. 48, 28. Let me erase this. And finally, the fifth one is simply going to be 100. So we'll just go ahead and do that. So it's going to be 100, and that's 64. So we've got 192, 168, 100, and then 64 only, and then 28. So those are going to be my network, 5 networks. Let me just erase everything here. And I'm going to take one of those networks, let's say this one here, to show you more details, information about that. So number one, I borrowed 3 bits. That's how many bits I borrowed. Previous was 25, I borrowed 28. That simply means I can have, I have how many bits are left for the host, since I already have 1 and then 3, so 4. So 4 bits are left for the host. So this is how many bits I borrowed. This is how many bits left for the host. Let me just put it in a form of an IP address in a binary so we'll understand what's going on here. So I got 192, 168, 100, and in this case, since this one is 16, so I'll put 0, 0, 0, 1, then 4 zeros. And now remember here, because we have a 28 prefix, so this is going to be the line that separates the network portion from the host portion. So this is network portion, this is the host portion. Okay, so the first available IP address is simply going to be the same thing, except this is going to be 17, whatever the IP address for the network plus 1. The broadcast simply is going to be me flipping all these zeros to 1. So I've got 1 here, 1 here, 1 here, and 1 here. This is the prefix, and this is supposed to be 1631. That's the prefix. That's the broadcast. Now the last available IP address is going to be 31. Now remember here, whatever is at the beginning is the same as this one. And they're going to have the same exact prefix, 28, 28, 28. Number of hosts I can have in each network is 2 to the power of how many bits do I have here for the host, which is 4, minus 2, which in this case is going to be 16 minus 2, 14. I can simply have 14 different hosts in each one of those networks. So this is again how we answer this question. Again, we are giving an IP address with a prefix, and you're asked to subnet it into a specific number of networks. Now, let's go ahead and move to the second part, where the question is, let me just copy this. And let me put it here. So now for case number 2, we are giving a number of networks that we don't know, but we know every single network should have a host of 12. So we're going to do the same thing we did before. This is how we start usually. 192, 168, 100. Dot. I'm going to come here and put the 8 zeros in binary. And in this case, since this one is 25, I know there's going to be 255.255.255.100000000. And now the line that separates the network portion from the host portion is the one that I just saw. Now, since you want me to have 12 hosts in each network, the question that we're going to ask is, how many bits do I have to keep to be able to get 12? Previously is how many bits do I have to borrow. Now, how many bits do I have to keep? And the idea, or the formula that we can use to answer this question is 2 to the power of the number of bits that we have to keep minus 2 should always be greater or equal the number that he's giving me, which is a 12 in this case. Now, we do the same thing here. If I keep 1, I will get simply 0. That's not acceptable. If I keep 2, that will be 2. 2 to the power of 2 is 4. 4 minus 2 is 2. That's not acceptable too. If I go and keep 3 bits, 2 to the power of 3 is 8. 8 minus 2 is 6. That's not acceptable. And now if I keep 4, 2 to the power of 4 is 16. Minus 2 is 14. And that is acceptable. So simply means I have to keep 4 bits to be able to get 12 hosts. Now, with that being said, now I can come here and say this is going to be the new line that's going to separate the host portion from the network portion. Okay? Now, at this point, I can simply tell you that we got ourselves in the position that we had in the previous case, case number 1. So, since I'm borrowing 3 bits, to be able to get the 12 hosts, my answer is going to be exactly the same thing that just like we did in case 1. So I'm not going to go through that because you already know what I'm going to be doing. Again, all these ones are going to be turned, all these zeros are going to be turned to 1. We're going to have a new prefix, which is 8, and I will have 8 different networks. And those 8 different networks are going to be 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1. And then finally 0, 0, 0, 0, 1, 1, 1, 1. So those are my 8 networks. All I have to do is take each one of them and replace it with this one and then do the calculation for all the networks, starting from network 1 all the way to network 8. Again, this part is exactly the same as the part that we covered in case number 1. So if you didn't understand it, just go back to the first part where I covered it and you should be good to go. Now, we're going to move on to the third case where we have different networks. We have a number of networks with different number of hosts for each one of them. And this is going to be a little bit longer. So let's go ahead and work on it together. Let me take this out. Let me extend the view a little bit here. And let's go back here and let's look here. So we have the same network IP address. We got network number 1 that contains 60 devices. So as I told you, do not look at those two at this point. Just ignore them as if they don't exist. We need to break down this IP address to be able to create a network that can host 60 devices. So what we're going to do here, we're going to do the same thing. 192, 168, 100, and then we have 0, 0, 0, 0, 0, 0, 0, 0. And here we got 255.255.255.1000000. 0. Am I missing? Yes, I'm missing one. Let's put 0 here. Now, my original line, it's here. Now, since I need to have 60-bit hosts in this network, I'm going to ask myself, how many bits do I have to keep to be able to get 60? Remember here, the equation is 2 to the power of that number of bits that we have to keep minus 2 should be greater or equal 60. Now, based on what I can tell you here, if you borrow 4 is not enough, 5 is not enough, 6 will be enough. 2 to the power of 5 is 32, minus 2 is 30, so that's not acceptable. But 2 to the power of 6 minus 2. Now, 2 to the power of 6, I think, is 64. Minus 2 is 62. And 62 is greater than 60. So we need to borrow we need to keep 6 bits here. And because we're keeping 6 bits, this will be my new line that will separate the network portion from the host portion. Now, based on what I said here, we simply can borrow only 1 bit. We can only borrow 1 bit. Now remember, the first thing you have to understand, this is going to be converted to 1. So the new prefix is simply going to be 26 instead of 25. And because I have 1 bit here, that bit could be 0 or could be 1. I'm going to use 0 for now. So for network 1, the IP address is going to be 192, 168, 100. And since I'm using 0, so it's going to be 0 with a prefix of 26. At this point, I know I answered number 1, and I took this out, and now I move on to the next case, or the next possibility, which is putting this as 1, and that's what I'm going to do. I'm going to come here and put this as 1. Now, at this point, I am going to consider that I have a brand new question, and for this question, I have this IP address, 192, 168, 100.64 and a backslash of 26. Okay? Now what I'm going to do after this point, I'm going to take this out, take all this out, and I am done with network 1. I found the answer for this one, and now my focus is going to be this one here. I'm not going to look at this IP address anymore. This is my IP address that I am interested in, which is how do I use this IP address to create a network with 5 devices only? Well, the idea is very simple. This is 26, So this is going to be 255.255.255.11, and then you got 6 zeros. And of course, what I need to do, let me just do it here. I'm going to cut this from here. Control X, Control V. Let's put it at the top here. And now I have to come here. For this 64 is going to be 0, 1, and then you got 6 zeros. And now remember here, my line is simply here. This is the network portion. This is the host portion. Now the question is, how many bits do I have to keep out of those 6 ones so I can get 5 devices? And the answer will be 3. Because 2 to the power of 3 minus 2 is simply 6. 2 to the power of 3 is 8. 8 minus 2 is 6. And 6 is greater or equal 5. So that is telling me that I have to keep 3 bits. And because I'm keeping 3 bits, that simply means I can... Sorry. Let me just take this out again. And let me click here. And let's just choose a different color. And this will be the new line that I have. So at this point, I'm keeping 3 bits here and I'm borrowing 3 bits to the network portion. So what is that supposed to mean? Again, the prefix is simply going to change now. And I will have all these 3 bits to be converted to 1. Okay, so the network 2 will have a subnet mask of 29. Why? Because originally I started with 26 and I added 3 bits, so that's 29. Now we know the first 3 parts of this IP address are simply the same. They're not going to be changed, so we're going to go ahead and put in 192, 168, 100, and a dot. Now here's the deal. Remember here, we are going to play with those 3 bits. Remember here, originally I have it as following: 0, 1, and then 0, 0, 0, and then I have 3 other zeros. And here, this is my subnet mask: 1, 1, and then 1, 1, 1, and then 3 zeros. Now let's just go ahead and put the lines back. This is the original line. This is the new line after I borrowed those 3 bits. So I have to focus on those 3 bits here, the zeros ones. Now we said we're going to have to list all the possibilities. So I can have a possibility of 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, then 0. So, sorry, not 0. Let me just go a little bit down. We got 8 different possibilities. And then we got 0, 0, 1, 1. And then we got 1, 1, 1, 1. So, for this network, network 2, I'm going to use the first one. So 0, 0, 0 to be assigned here. And when you put 0, 0, 0 and you convert the whole thing back to decimal, you're simply going to get 64. So at this point, I am done with network 2. And let's move on to network 3. Now, before we move to network 3, I have to pick one of those IP addresses for network 3. And in this case, I'm going to choose this one. Of course, you can choose any one of them, but I like to choose this one. And for that reason, I'm going to come here and change this one to be 1. And at this point, I'm going to stop, take everything out, or let me just take this two out, and I'm going to cut this, Control V, and I'm going to put it here at the top, just in case I need it again. And remember here, this is my IP address, so let me just take this one away. And let me just go ahead and print it at the top here. So my new IP address is going to be 192, 168, 100, /29. And this part here, I need to convert this to binary. So this is going to be 64 plus 1248. So this is 8. And that will make it 1272. Let's see if that's the case. Yeah, it should be 72 because this is 64. This is 8, 16, 32, 64, and this is 8. Yep. So 2072. Okay. Now, with that being said, I can take this out. And now all I have to do at this point that I am done with this network, and I'm going to start talking about network 3, I need to subnet or break down this IP address so I can have two hosts. So remember here, this is 255.255.255 dot something. I'm going to go down and do the something. This is 29, so it's simply going to be 25, 26, 27, 28, 29, and then 3 zeros. And for this 27 is 0, 1, 0, 0, 1, and then 3 zeros. And my line that separates the network portion from the host portion is simply this one here. And I have to ask myself, how many bits do I have to keep to be able to create a network with two devices? And the answer is simply going to be 2. 2 to the power of 2 minus 2 is simply equal to, and 2 is actually greater or equal to. So I'm going to keep those 2 bits. And because I'm keeping those 2 bits, I am simply going to create a new line here. And now I'm going to borrow this bit here. And because I'm going to be borrowing this bit, I simply have 2 possibilities for 2 networks that I can create. The first network is simply by using 1, 0, and the other one to use 1. Now remember here, this is the subnet mask, so this is supposed to be flipped to 1. As a result, I'm going to get 192, 168, 100, and I'm going to put this part left, and this is going to be 30 because it was 29, and then I borrowed 1, so it's 30. Now, what am I going to put here? It relies on which one I'm going to choose. If I'm going to choose this one or choose this one. Since I'm choosing 0, I know this is going to be 72. And that will be my network 3. Now, of course, if you're going to create a network 4, and if network 4 need to have 2 devices also, well, I can simply just use the 1 and assign it to network 4. But he's not asking for that, so don't worry about that part. But that's, again, just in case. Now, if I need to create another network with more devices, I do have the possibilities here to choose from. So, bottom line here, the answer for this question is simply the following. This is for network 1, this is for network 2, and this is for network 3. And that will be the end of this video. I hope this explanation helped a little bit. This is something you need to master. You need to be really good at. So hopefully this helped.